Welcome to the Explainer. Today, we've got a genuinely fascinating architectural shift to unpack. We are going under the hood to completely demystify the technical mechanics and the sheer power of Claude Opus 4.8's newest sub-agent engine. We're looking directly at what makes this release fundamentally different, how it manages massive-scale tasks autonomously, and what that actually means for your daily development cycles.
Okay, let's dive into this by addressing the elephant in the room. You know the drill, right? You use an AI tool to build an app or refactor a code base, and it gets you, 80 to 90% of the way there? It gives you a fantastic start. But that final 10%, that is where you're left doing the tedious manual bug fixing. You're constantly going back and forth just trying to get the application over the finish line. It's a universally frustrating problem. But the dynamic workflows we're looking at today, they aim to completely bridge that gap.
Here's our roadmap for this deep dive. First, the dynamic workflow engine. Second, analyzing token usage patterns. Third, automated QA and reliability. And finally, real-world AI performance. Section 1. The dynamic workflow engine, unlocking autonomous coding. To really understand why 4.8's workflows are so incredibly effective, we have to look at a major course correction Anthropic made. Think back to Opus 4.7. It was highly literal, right? It was just a bit too precise, which honestly made it pretty rigid. But Opus 4.8 has been engineered to interpret ambiguity much, much better, bringing back this highly creative edge. And that is absolutely crucial, because handling messy, open-ended ambiguity is the foundational requirement for true agentic madness. You just can't have an autonomous agent if it completely freezes the moment your prompt isn't perfectly literal. So, what are dynamic workflows? It's an exclusive feature rolled out for enterprise, team, and max plans. When you activate this engine, it literally spawns hundreds of sub-agents to tackle massive, complex tasks entirely autonomously. We are not talking about writing a single simple function here. We're talking about heavy-duty jobs. Think complete code-based refactoring and large-scale architectural migrations, the whole shebang. Let's look at how this plays out. When tested on a really complex task, like building a personal finance dashboard entirely from scratch using Claude code, the dynamic workflow follows a strict autonomous sequence. First up, the subagents map out a plan, feature by feature. Second, they autonomously build the system architecture. Third, and this is a real game changer, they double-check their own work. And finally, they actually generate and upload mock data specifically for QA testing. It is a complete end-to-end development cycle, executed by hundreds of coordinated AI agents with zero human intervention. Section 2. Analyzing token usage patterns, the cost of automation.
Now, what's really interesting about this slide is the computational fuel required to make all this happen. 45. That's the number of minutes this system ran continuously just to build that one personal finance dashboard. For almost 45 straight minutes, the dynamic workflow was just humming along in the background, planning, building, checking, and testing. Now, from a user perspective, that feels like an absolute eternity to wait for a single prompt to resolve. But remember, it is executing an entire project lifecycle.
And all that runtime, it translates directly into a staggering 300,000 tokens. By tapping into Opus 4.8's massive 1 million token context window, this single 45-minute operation consumed an immense amount of computational resources for just one localized application build. That is a massive burn rate. But let's contextualize that shock for just a second. 4%. Despite that extreme 300,000 token consumption, testing showed that this heavy fuel burn only accounted for a mere 4% of a max plan's weekly usage limit. So while the absolute numbers look incredibly high at first glance, the actual impact on an enterprise or max-tier account is surprisingly manageable. Basically, it means you can routinely run these heavyweight workflows without instantly throttling your account. The crucial takeaway here is this. You are actively trading computational fuel, your time and your tokens, for a 100% finished product. You're paying a steep upfront price, letting the machine churn away for nearly an hour, but that is the necessary fuel to cross that frustrating final 10% gap we talked about at the very beginning of this explainer. Section 3. Automated QA and reliability. Flawless execution. This right here is where the true reliability of the system just shines. The dynamic workflow didn't just write the code, it generated its very own custom QA testing checklist. It flawlessly interacted with the mock data it uploaded itself, ensuring all those dynamic numbers populated correctly on the dashboard. It even went a step further right in the middle of the process and successfully optimized a mobile version of the site. And the final result after all of that? 0 faults found. Literally no manual bug hunting, no need to string together external plugins. The AI essentially acted as its own highly rigorous QA department. I think many developers will completely agree with this sentiment. I'd rather have it 100% done and go overkill on this option, rather than 90% done and then me fixing little bugs. This perfectly summarizes the value proposition of the new effort maximum setting available in Opus 4.8. You can intentionally choose this overkill route. For solo developers or lean teams, letting a massive workflow run in the background while you go focus on other things is just infinitely more valuable than getting a fast, incomplete draft that demands hours of manual debugging. And this brilliantly illustrates our transition into Section 4, Real-World AI Performance Beyond the Vibes. So there is a massive divide right now in how AI is evaluated. On one side, standard corporate benchmarks are often cherry-picked, highly curated, and run in very static environments. Companies basically just select the 6 tests they win and publish those to their blogs. But on the flip side, we have the Deep Sweep benchmark. Deep Sweep evaluates real-world software engineering tasks built entirely from scratch, so the models can't pre-train on them. It tests high diversity and uses short prompts. Why? Because in the real world, developers don't always sit around writing elaborate, perfect prompts. They wing it, and they fully expect the model to just figure out the ambiguity. Impartially observing the realities exposed by Deep Sweep is fascinating. This kind of rigorous, real-world testing tends to expose weaknesses in heavily marketed models, like Gemini 3.5 Flash, which often struggles with intermediate to advanced tasks despite claiming really fast benchmark speeds. Conversely, Deep Sweep highlights the zero-shot strength of models like GPT 4.5 in agentic environments, meaning its ability to succeed on the very first try without any prior examples. As for the new Opus 4.8 architecture we've been discussing today, well, the industry eagerly awaits its final ranking on this board. But given its new ability to handle ambiguity and spawn these dynamic workflows, expectations are incredibly high. Which brings us to the core takeaway of everything we've analyzed today. It's simple, really. Real-world adaptability outshines static benchmark scores every time. The true test of an AI model isn't how fast it can answer a pre-trained multiple-choice question. It's about how it handles the messy, ambiguous reality of actual project development. It's about whether it can deploy dynamic subagents to autonomously plan, code, and QA test an entire application without needing its hand held by a human developer. So I want to leave you with a final provocative thought. Is trading massive token usage and letting a machine run for 45 solid minutes for 100% automated task completion the future of your workflow? Are you ready to hand over the reins? Let the subagents do all the heavy lifting and step away from manual bug fixing forever? It is a fascinating shift in how we build technology. Thank you so much for joining me for this explainer, and I can't wait to explore the next big breakthrough with you soon.